In this lesson, we will study the button and put it into practice. A button is a fairly simple device that closes and opens the electrical network. In the electrical circuit, the button is indicated as follows. The button can be found in almost every electronic device, in the computer keyboard, in the phone, in the TV remote control, and many others. Buttons can be of two types: switches with a fixed position and tacked buttons that return to their original position. In our case, the module number 24 has tacked buttons. Now let's move on to practice. We will try to control the LED with the button. The connections are as follows. The two pins on the outside are responsible for power, that is 5V and GND. The middle pin is the signal pin. It needs to be connected to digital pin number 2 of Arduino. Also, you should connect the circuit to ignite the LED. We also see a button connected to pin number 2. Here you might have a reasonable question. Why did we also ground the button through a 10 kilo ohm resistor? To answer this, you can imagine that we connected the button without any additional resistors. Here, between pin number 2 and ground, there is a small capacitor. It is capable of accumulating charge. Many microcontrollers have this feature. Now imagine that we press the button. The current starts to run from 5 volts straight to pin number 2, charging the capacitor along the way. Arduino successfully detects that the button was pressed. But after we unpress the button, contrary to our expectations, the microcontroller continues to think that the button is pressed. That is because the charged capacitor gradually gives the accumulated charge to pin number 2. This will continue until the capacitor is discharged below the level of logic 1. In addition to that, if the output of the microcontroller is not connected to either plus or minus, then any signals passing nearby will interfere with this contact. Because of these noisy signals invisible to us, the microcontroller will falsely work as a pressed button. To prevent this from happening, we use a pull-down resistor. When the button is pressed, the current will follow the path of least resistance, that is, pin number 2. But as soon as the button is unpressed, the charged capacitor will discharge to the ground through the resistor. Now, in this connected state, Arduino will receive 5 volts from the pressed button. This is called logic 1. When we unpress the button, this digital pin is disconnected from 5 volts and connected to GND, that is 0 volts. This is logic 0. Such logic is called digital logic. For this reason, all 13 pins are digital pins. The connection is ready. Now open the Arduino program and write the commands. Button output number, LED pin number. Initialize the LED output as an output. Initialize button pin as input. Read the state of the button value. Turn on the LED. Read the state of the button value. Turn off the LED. Everything is working well. And so, what do we see? We can turn the LED on and off using the button. Let's now learn how to use the button to control the level of the LED scales. Let's start connecting. Disconnect the LED and connect the LED scale to Arduino. We do it like this. First connect GND to GND. Then from pins 3 to 12 of Arduino, we connect to the pins of the LED scale in the following sequence. Everything is ready. Now open the Arduino program and upload the sketch of this project. You can download the sketch in the lesson materials. After uploading the sketch, we can run the code. And so what do we see? With the help of a button, we can control the level of the LED scale. Congratulations! We have gone through all the basic principles of the button and have put it into practice.